All right, this is Honors Algebra 2 Pre-Calculus. We're doing 5.3 in Pre-Calc, which is solving trig equations. So, as you recall from previous videos, when we have an equation that has a coefficient inside the trig function, we need to go around the given interval multiple times. So let's go ahead and walk through this. Okay, so here we have 2 sine 3 theta plus 1 equals 0. So the first thing we're going to do is solve down to the trig function again, right? So we're going to use SADMAP, right? So we're going to get 2 sine of 3 theta equals negative 1. We're going to get sine of 3 theta equals negative 1/2. Cool. Okay, so this is saying that the y on the unit circle is a negative 1/2, but because of this 3 on the inside, I'm going to go around this interval 3 times, okay? So what I'm going to do is I'm going to go ahead and say that this, right, so we know that the y on the unit circle is a negative 1/2 here and here, right? So I'm going to go around 3 times. So my theta, my 3 theta rather, right? My 3 theta is going to be, this would be a 7 pi over 6, right? And this would be an 11 pi over 6. That's my first time around the interval, okay? But then I'm going to have to go around again. So I got 7 pi over 6. I'm going to go around again. Well, 7 pi over 6 plus 12 pi over 6, which would be a full circle, right? 2 pi over 6 would be a full circle, would be a 19 pi over 6. And then if I did the same thing for the 11, right, I would get a 23 pi over 6, right? And then I'm going to go around one more time, right? I'm going to go around, so that's my second time around the circle in red, right? That was my second trip around the circle. I'm going around 3 times because it says a 3 theta, and you'll kind of see why in a second. When I go around one more time, again, I'm going to add another full circle and say, hey, I went one more time around the interval, right? So I think I get a 31 pi over 6, right? And I think I get a 35 pi over 6. All right, so that's my third time around the interval, right? It was a 3 theta, I went around 3 times. Why did I go around 3 times? Well, because now I still have to solve for theta, so I'm going to divide literally all of these by 3. And what's going to happen is I'm going to get that the answer is theta equals 7 pi over 18, because a 6 divided by 3 would be 1/18, an 11 pi over 18, a 19 pi over 18, a 23 pi over 18, a 31 pi over 18, and a 35 pi over 18. And notice that this is just a hair smaller, so this is still in the window from 0 to 2 pi, right? Because 2 pi in 18ths would be 36 pi over 18, and 35 pi over 18 is smaller than that. So this is my answer to A, right? This is my answer to A. And that's all the values that fall in that window. And I had to go around 3 times. If I had gone around a 4th time, that 4th answer I got, right, that next answer would have been too big. It wouldn't have been the interval. So if you're ever not sure how many times to go around, you could go around a bunch of times, and then when you divide by that 3 to solve, you'd figure out that some of your answers are too big and you could cross them off. But the shorter, easier way to think about it is if this is a 3, you have to go around your interval 3 times. Now, B is actually a little bit easier, weirdly. I could either do B by writing this, which is fine, right? So there's 2 ways to write B. I could, so for B, I could either, right, list the A answers, right, but with the plus 2n pi, which isn't wrong, right? I could list all of them. So I could do 7 pi over 18 plus 2n pi, and 11 pi over 18 plus 2n pi, but you can imagine that this gets a little bit tedious. Or 19 pi over 18 plus 2n pi. Geez, I'm only halfway through. And 23 pi over 18 plus 2n pi. And this is not wrong, but I'm going to show you a better option in a sec. 31 pi over 18 plus 2n pi. And 35 pi over 18. Wow, this is still happening, plus 2n pi. Whew, that took a while. Or, and here's kind of a cool trick, or I could just forget about going around the circle multiple times. I could say, wait a second, 3 theta was the 2 points that I could see on the circle, the 7 pi over 6 plus 2n pi, and the 11 pi over 6 plus 2n pi, right? And then what I could do is I could divide everybody by the 3 to solve, and I could get that theta is 7 pi over 18 plus 2n pi over 3, and 11 pi over 18 plus 2n pi over 3. And what's crazy is that this will actually, like if I check, this will fill out the other answers, right? So for instance, because if you think about it, like, so this would be another way to write it. So just to verify this checks out, so I'll show you this checks out. Right, so just to show you it works, right? Let's say I picked n was 1, right? If n was 1, I'd get 7 pi over 18 plus 2 pi over 3, which if I convert the 2 pi over 3 into 18ths, right, that would be 7 pi over 18 plus, I'd be multiplied by 6 over 6, right? So 12 pi over 18. Well, that would give me the 19 pi over 18. Well, look at what your second answer right here was. That was that answer, right? And if I picked n as 1 for the other one, right, if n were 1 for the other one, I would get 11 pi over 18 plus 2 pi over 3, which is 11 pi over 18 plus 12 pi over 18, which is sure enough that 23 pi over 18, which is, again, if you look up here, that's this next one, right? That's this one, 23 pi. So you could do it this way. So you could either list it, like if you did all that work for A, you could totally do this and be like, cool, this is my answer for B, right? Or you could do the faster version, which is literally just taking the two answers that happen on the circle, like the two that actually happen on the circle, and then divide by the 3. All right? You're going to go ahead and try a P7. So notice that there's a 2 on the inside, so you're going to go around the circle twice. So cosine of 2 theta is going to be a 1 over root 2, or that's the same as saying cosine of 2 theta is root 2 over 2. So we're looking for where the x on the unit circle is a root 2 over 2. Well, that's going to happen here and here, right, at pi over 4 and 7 pi over 4, right? But because of the 2, I'm going to go around twice. So my answer to A is going to be 2 theta equals pi over 4, 7 pi over 4. That's my first time around the circle, right? That's time number 1. Time number 2 around the circle, I would be adding a full circle, which is 8 pi over 4, right? Because 2 pi, right? 8 pi over 4. So that would be a 9 pi over 4 and a 15 pi over 4. That's my second time around the circle. So if now I divide everybody by 2 to solve, I'm going to get that my answer to A is pi over 8, 7 pi over 8. It's a 7. It just doesn't look like a 7. 9 pi over 8 and 15 pi over 8. So that's my answer to A, right? And then for B, there are 2 ways to do the answer for B, right? So for B, you could either list all of the A answers and just add 2n pi, right? So pi over 8 plus 2n pi, 7 pi over 8 plus 2n pi, 9 pi over 8 plus 2n pi, and 15 pi over 8 plus 2n pi. That's fine, right? Or you could say, wait a second, I get that theta was just this value, 2 theta was this value plus 2n pi, and this value plus 2n pi. So if I divide everybody by 2, I'm going to get pi over 8 plus n pi and 7 pi over 8 plus n pi. And I promise you that those are the same answers. So you could either do this or do this. Either of them would be fine. All right. So last 2 examples. So far, everything we've done has either been doable by our knowledge of the unit circle or it's been something that has no solution. Let's talk about what happens when that's not the case, because we're going to have to use arc trig or inverse Trig's functions to solve. So here, we've seen this before. There is no GCF, but I have a squared term. So I'm going to have to use a Pythagorean identity, and I know that there is a Pythagorean identity, right? I know that there's a Pythagorean identity that tangent squared plus 1 is secant squared. So I'm going to go ahead and say, hey, this is tangent squared theta plus 1 plus a tangent equals a 3. So if I move everybody to one side, because in order to factor, I have to have a 0, right? I'm going to get tangent squared plus tangent minus 2. My u is tangent. So I'm going to get u squared plus u minus 2 is 0. So that's u plus 2, u minus 1. So tangent theta plus 2, tangent theta minus 1. Either tangent of theta plus 2 is 0, which means tangent of theta is a negative 2, or tangent of theta is a 1, and that's fine. Okay, so this one I can do on the unit circle. Right, tangent of theta is 1 on the unit circle. That's when y on the unit circle on top of the x on the unit circle is 1. So that's when x on the unit circle and y on the unit circle are equal. And that happens right here and right here. So that answer is definitely going to be a pi over 4 and a 5 pi over 4. Okay, that's fine, right? So that's pi over 4 and 5 pi over 4. But this one's tricky because this one actually doesn't show up on the unit circle. Like tangent is never a 2 or a negative 2 on the unit circle, so theta is going to end up being the arctangent of a negative 2. And that's the best I can do because it's not on the unit circle, but it is a solution. So it's not like saying that sine is 2, because sine will never be 2. If you picture a tangent graph, right? Tangent graphs look like this. They hit every y value forever, right? So tangent can be a negative 2. We just don't know that value. Now, you could also use a calculator to find it, but it's okay to leave your answer as the arctan of negative 2, right? So let's go ahead and walk through. Let me double check. For A, we wanted all of the values on the given interval, right? Well, arctan is negative 2, right? So we can actually, let me go to mode and make sure I'm in radians, right? So I can do inverse tan of negative 2 and get this value, right? So in radians, right? So that's basically saying in radians, that's saying somewhere down here, right? Because this is 0 radians. This would be a negative 1.5. So that's somewhere like here, right? So the other place that value is going to happen is over here. So if it's happening down here at negative 1.1 blah, 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 it's also happening if you go from pi and go backwards 1.1. So my answer to A is that there are actually two values, right? So the answer to A is, I'm sorry, there's two different sets of answers. There's pi over 4 and 5 pi over 4. Those are the two I can get from the unit circle. But there's also, if I'm giving exact answers, there's the arctan of negative 2, and there's pi plus that value. And the reason I said plus that value is that arctan, let me rephrase. It's actually not the arctan of negative 2. Hold on. So the three values that I would want are this one, right? So see how I have this negative whatever, right? So this value right here would be that arctan, which is a negative 1 point whatever, plus a pi. That would be that angle. And this angle doesn't actually fall in the window from 0 to 2 pi. So what I would need to do is I would need to say this is 2 pi plus that angle. So my other two angles are arctan of negative 2 plus pi and arctan of negative 2 plus 2 pi, or I could give decimal equivalents. So I could do plus pi, which would be, so that would be approximately 2.034. Or, and then the other one would be that arctan of negative 2 plus a full circle. So 2 pi, right, which would be a 5.176. So those are my four approximate values. Now, once I find those for A, it's a little bit trickier for B, right? It's not so much that it's tricky. I mean, once you find those, honestly, the lazy way to do B is literally just write those four answers with a 2n pi after each one. So for B, right, my answers would be theta is pi over 4 plus 2n pi and 5 pi over 4 plus 2n pi, although those two are directly a straight line across from each other. So you could, and in fact, so are these, right? These are both straight lines, right? And the other one would be this arctan of negative 2 plus pi plus 2n pi. And the arctan of negative 2 plus 2 pi plus 2n pi, right? Now, I would argue that both of these are a straight line across from each other, and both of these are a straight line across from each other, right? So the easier way to write B, right, the other way to write B is you could write that theta is pi over 4 plus n pi, and the arctan of negative 2 plus, honestly, you could just say 2n pi for full circles, because you could say, hey, I get that this is the spot that I want. I want things that are coterminal to it, so 2n pi. So that's the easier way to write B. I'm not going to ask you to do this very often. I just want to show you that just because something's not on the unit circle doesn't mean you can't find the answer. All right, so let's go ahead and finish this one out. So this one, actually, you don't have to substitute a trig function in because they're both cotangents. So you're going to get u squared minus 6u plus 5 is 0. That's a u minus 1 and a u minus 5. So either cotangent of theta minus 1 or cotangent of theta minus 5 equals 0, right? So that's going to give you cotangent is 1, which we already saw is actually those same two spots. It's here and here, right? Because that's the x on the unit circle on top of the y on the unit circle. Or cotangent of theta is 5, and that's not on the unit circle. You're going to have to use the arc cotangent of 5, right? So I get here that this answer is pi over 4 and 5 pi over 4, right? And then for this one, I'm actually going to get two possible answers, right? So the trick is that there's no good way to do arc cotangent, right? So this is tough in a calculator because there's no arc cotangent. The easier way to do it is to recognize that if the cotangent is 5, then the tangent is the reciprocal of that. So what I would suggest you put in instead is that you put in the arc tangent or the inverse tangent of 1/5, right? So if I do inverse tangent of 1/5, right, I'm going to get this value, and you'll notice that that lives somewhere in quadrant 1, like right here, right? That means the other one is down here, right? Essentially pi units away, right? So basically my answer to A is going to be that theta is pi over 4, 5 pi over 4, that's a 5, it just kind of looks like a 6, inverse tangent of 1/5, and the inverse tangent of 1/5 plus pi radians, right? Because that would be pi radians off. So those would be my answers to A. For B, I'm going to argue that you should just go ahead and skip to the shortcut, which is that these two make a straight line. So I'm going to get pi over 4 plus n pi, just a half a circle, right? And that, again, these two are going to make a straight line, so my other one is going to be the inverse tangent or the arc tangent of 1/5 plus n pi, and those would be my two answers. So I get that that's kind of hard, but again, it's not a skill I'm going to make you use often. I just want you to be aware that just because something doesn't show up on the unit circle doesn't mean it's not a value that exists. And that's it for 5-3.